Good morning, everyone.
Good
Good
morning,
morning,
ma'am.
ma'am.
Good morning, ma'am.
Okay, so where did we stop in the last class? Yeah, can somebody answer me from the class? Where did we stop? I can't, your voice is not, your voice is not clear. Can somebody else answer? Her voice is not clear. Somebody else answer.
If Feli fails, ma'am.
So we stopped at that point, like, okay. What is that experiment number?
3, ma'am.
Okay, experiment 3, right? So what is it? What is the name of the experiment? Can somebody just tell me that? So experiment 3 is all about? What is experiment 3?
Decision-making statements and looping statements.
Yes, we have looked into the decision making statements, and today we'll look into the looping statements. What are the two loops that are available in Python?
While and for, ma'am.
While and for.
While and for. Okay, so I'll be showing you how to use while loop inside a program, and I'll also show you how to use for loop inside a program. Okay, fine. Let me get back to your terminal. Let me share the screen. So I hope you can see the terminal.
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Yes. Okay, now I'll be writing a program to show you how to use while inside a program. For that, I'm creating a file. So the name of the file is, I say pri .py. So the name of the file is pri, and which should be of .py extension because this is Python program. Okay, so what exactly I'm doing in this particular program is how I'm going to use this. I want to find whether a given number is prime or not. So what the user will be doing is, so the user will be giving an input. So what is the input that the user will be giving is, he will be giving a number. Okay, so the user will be giving a number, and you'll be writing an algorithm, so which is in turn turned to a code, and your program will actually give the output stating that the number is prime or not. Okay, so this is what is the prime or not. So this is what is the program that I'm going to write. Okay, so there will be a certain input from the user. The input will be giving the user will be giving the input, which will be a number, and your program will process this input and then say whether the given number is prime or not to the user back. Okay, this is the output of it. So let us start writing the algorithm. Okay, so before writing the algorithm, let us just understand what is a prime number. So 12 is not a prime number, not a prime. Okay, fine. And so 9 is not a prime number. Okay, not a prime number. 7, is it a prime number? Yes, it is a prime number, is prime. Okay, so we are having different 5, is it a prime number? Yes, it is a prime number. Okay, so we know that the prime numbers are odd, but all odd numbers are not prime. Let us just try to understand the internal concept of being prime and not being prime. And there can be many algorithms, efficient algorithms, optimized algorithms for the prime number, for determining whether a given number is prime or not. But we'll be sticking on to the basic algorithm. So what is a basic algorithm? So the concept that I'm going to include in my coding is that I'll be finding out the factors of a number, and if there are factors then I'll say that it is not a prime number. So let us look into the factors of 12. So which is 1, 2, and then 3, and then 4, and so on, 6, and all that. So these are the factors of 12 and 12 itself. And coming to 9, it is 1, 3, and then 9 over here. And coming to 7, it is 1, and then 7, and 5, it is 1 and a 5. Okay, so why I have given not prime and prime numbers over here is so that you will understand the algorithm better. So consider the non-prime and prime numbers. You can see that any number is divisible by 1 and itself. Say 12, 12 is divisible by 1 and also by 12 itself. And 9 is divisible by 1 and 9 itself. And 7 is divisible by 1 and also by 7. And 5 is divisible by 1 and also 5. Okay. But here what we understood is the essence of this is that every number is divisible. Okay, so is divisible by 1 and itself. Okay, so this is the basic understanding that we have understood with these examples. Now coming to this, every number is divisible by 1 and itself. Then what is a prime number? Okay, so from this, if I just have to define a prime number will be the one. A prime number will be the one which will be divisible by 1 and itself only. Okay, so there is a difference between non-prime and prime, that if it is a non-prime, it will be having other factors other than 1 and itself. If it is a prime number, then it will be having only 1 and itself only as the factors. So when every number is divisible by 1 and itself, when I have to, it means that I need to check from 1, 2, 3, 4, 5, 6, and so on till n. Okay, so I need to find out whether 1 is dividing it or not, 2 is dividing it or not, properly dividing it or not, 3 is dividing it or not, 4, and so on till n. So I need a loop to perform the same operation again and again. So the algorithm is forcing me to have a loop in it. Okay, so now the choice is what kind of loop you will be taking, whether a while or for depends on your choice. Okay, I can pick a while or for because I'm repeating the same operations again and again from 1 to n. Okay, till n, because the user will be providing a number which will be taken into an n. So I need to process it, find out whether it is divisible or not from 1 to n, 1 through n. I need loops. Okay, so this is how I conclude whether I need loops or not in my program. Okay, so I cannot simply directly start writing a loop. Based on the understanding of the algorithm, what exactly is happening in the algorithm, based on that understanding, I'll pick whether I need loops or not. In the loops, again, there are various variations of it, and whatever is I think sir have discussed the difference between while and for, when you will be choosing while and when you will be choosing for. So based on your thing, you will be choosing application, you will be choosing the loops. Okay, so herein I am picking while for my algorithm. Now let me make the algorithm even better. Now I understood that every number is divisible by 1 in itself. So there is no point in checking for whether it is divisible by 1 and whether it is divisible by n. It will be good that I check for from 2 to n minus 1. Okay, so there is no point in checking for 1 and itself because every number is divisible by 1 and itself. Now here, taking this point as a highlight for my algorithm. So prime number is the one which is divisible by 1 and itself only. So what I'll do is I'll count the factors. Okay, so I'll count the factors. So initially, I'll put a variable f, and initially I'll make it 0. Okay, so meaning that there are no factors for the prime number. And if it is divisible, I keep incrementing f. Okay, so I keep incrementing f, and then what I do is if the value of f is greater than 0, then it means that it is not prime. Okay, so it means that it is not prime. And if the value of f is still 0 after performing all the operations from 2 to n minus 1, and still if f value is 0, then I say that it is prime. Okay, so this is what exactly you need to do before writing a program. And you should not directly jump into writing your logic and all that. There is many things like how you construct your algorithm is the very important thing that you do. So this is what I'm doing. Okay, so this is what I'm trying to implement in my program. Now I'm trying to make it even better. Okay, so how I'm trying to make it better is here I said like I'm trying to count the number of factors. Okay, so even if it get one factor, meaning that if it is not having any factors, as I'm saying that if it is 0, still after dividing it with all these numbers, still if it is 0, then it means that it is a prime number. For not prime, we are counting the factors. Now counting all the factors is not needed for me because I'm not counting the number of factors. The question is not that. The question is like whether a given number is prime or not. That's it. You just want to tell that it is prime or not to the user. So the question is not asking me to count the number of factors of a number. It is just asking me to tell whether it is prime or not. For that, what I'll do is, as soon as this f increments to 1, for example, f becomes 1, then I'll stop it. Okay, so I'll not continue further. For example, if you take 12, okay, so if you take 12, first what I'll be doing is I'll be dividing 12 with, I'll be performing a modulus operation which will tell me whether it is completely divisible or not. If 12 is equal to 0, okay, so what happens is that if 12 is divisible by 2, it means that 2 is a factor of it, so meaning that it is not a prime number. So is there any point for me to continue further? So saying that 12 is equal to 0, actually the process is that, but I needn't continue further with 3 and 4 and 5 and all that. As soon as I know that at this particular point, I came to know that it is having a factor other than 1 in itself. So it is better I stop the execution because there itself I came to know that it is not a prime number. Okay, so that's what I'm going to do over here. If it is divisible, then I'll just set the factor to be 1 and I'll come out of the loop. To come out of the loop abruptly, because I'm not turning the loop till n minus 1, as soon as it is divisible by 2, I'm checking whether it is divisible. If it is not divisible, then I go with 3, and then if it is not divisible, I go with 4 and then 5 and 6 and all that. But as soon as I know that it is divisible by 2, there is no point in continuing from 3 to n minus 1. So I'll be using another concept from your Python, which is a keyword again, which is called as break, which is a jump statement. What exactly break does is it comes out of your loop, okay? Without completing the full iterations, it comes out of the loop. So this is exactly the logic I'm going to apply. So this is my algorithm to solve this particular problem. So with this idea, so now I have a clear-cut idea of how I'm going to solve this problem. Now with this understanding, I'll straight away get into writing the code. Right. So what I said like I'm reading the information from the user. So I'll be saying num is equal to, I'm reading an integer from the user. So this is all I'm doing to read the information from the user. So the user will be entering a number. So enter n. So I'm asking him to enter a number or whatever. You can be more specific if you want. So then, this is what I did. And after that, as I said, I'm having a f over here, which is initially 0. If it is still, stays 0, then it means that it is a prime. Okay, so if there is any factors that I found in the middle, I'll change the value of f to 1. Okay, right. So if num is greater than 1, this is what, because 1, you cannot check for 1. If the user gives 1, then you will be just saying that it is a prime number or whatever, but the number has to be greater than 1. Okay, for that we are writing the logic. So let me give indentation over here. And now I am, you know that what are the things that the while loop will be having. So the while loop need to have an initialization, and then it need to have a condition, and then it needs to have an increment and decrement. So these are the three constructs that the while loop will be having. any looping construct will be having. So I'm taking a looping variable which is I is equal to 2, and I'm initializing it to 2. So this is what is initializing. I is a looping variable and 2 is I have initialized it to. And then so this is my while loop. So I said I is less than num. So I started iterating it by making this condition. So you can see that in case if I'm giving the value to be 12, so the loop should iterate from 2 to n minus 1, which is 11. Okay, so this is what I mentioned. Like I'm not checking for one end itself, because there is no point in checking, because every number is divisible by one end itself. So I think you understood this point, which I discussed in the algorithm. So now after this, what I'm doing is I'm entering into the loop. So now comes my logic. So I'm checking for num. Okay, so mod it should be I, okay, is equal to 0. So there should be a condition over here. So this is an if condition. So I'm saying if num mod I is equal to 0, okay, meaning that it is divisible. If it is divisible, as I already told you that I am, if it is divisible, I already told you what I'm doing. What I am doing, I will be setting the f value to be 1. So I'll be setting the value of f to be 1. Okay, so why I'm doing that is to know that it is having more factors other than 1 in itself. So that's what I did, and it's very important for me to come out of the loop, because I just want to save the time. Time complexity is very important thing when you are executing your programs. Your program should execute in less time. So I'm just doing that, and then I need the increment and decrement operator. So you do not have that I plus plus and all that in Python. You just need to say I is equal to I plus 1 and all that. So I just completed writing my logic according to the algorithm that I already told you. Okay, so if f is equal to 0, then I'll be writing that print statement, and I am saying number, okay, is prime. Okay, so number is prime. So I need to put this in single quotes. Okay, fine. And else what I'm saying is it's not prime. Okay, right. So that's it, girls. So this is what I have adopted to find out whether the given number is prime or not. If you want, you can just write down the comments. Okay, so I'm putting a comments. Check number is prime or not. Prime or not. Okay, so see, I have taken more time to explain the algorithm rather than writing the code. Okay, so this is very important. Once you get clarity on what exactly you should be doing, then writing the code will take very less time. So let us execute this and see. So the indentations are correct now. Okay, I hope the indentations are in the same line. Okay, fine. Now, so to execute, I should be saying Python, then I say pri .py. Okay, so it's asking me to enter a number. So let me give a non-prime, so which is 56, and it's saying 56 is not prime. So let me check for the otherwise. So let me give 17. Okay, so 17 is prime. So I hope like you understood this. So this is how you will be using a while in a Python program, right?
Yes, ma'am.
So let us move on to the next experiment, wherein I'll be working with for loop. So I'm taking the same program file, and I'll be writing your I'll show you how to give a for loop in a program. So here what I'm trying to do is I'm trying to generate, okay, so generate Fibonacci series. Fibonacci series, I'm trying to do that. So you all know that what is Fibonacci series. So Fibonacci series starts with 0 and 1. These two are considered to be the seed values, so seed 1 and seed 2. And the next number will be the sum of the previous two terms. So it will be 0 and 1, which will be 1. And the next term will be the sum of the previous two terms, which will be 2, and then a 3, and then a 5, and then an 8, and all this. Okay, so and then 13 and all this. So you can see that the number keeps on growing very drastically, and this is considered to be the Fibonacci sequence, okay, a series. Where do you use this Fibonacci series? These Fibonacci series are used in many algorithms in computer networks algorithm to generate the keys, and in many places this series is used. Okay, so the term, okay, one of the terms of the Fibonacci series can be used in algorithm to calculate something else. Okay, right. So now the concept is not to find out whether the given number is there in the Fibonacci sequence or not. Here we are generating the Fibonacci sequence. Okay, now the problem statement is that what the user will be giving. Okay, so what is the input and what is the user will provide us. Okay, so the user will be providing us the number of terms. Say for example, the user wants Fibonacci sequence till fifth term. Okay, so meaning that then I'll be getting all this. Okay, so all this till the fifth sequence I'll be getting. So like that, the user will be mentioning like I want 7 terms, 7 Fibonacci terms from the beginning. Okay, so then all the 7 terms from here will be printed. So this is what the user will be providing, and you will be generating the Fibonacci sequence. Okay, right. So this is the algorithm, and I'm taking a for loop to generate this Fibonacci sequence. And I'll be turning because the first 2 terms are already there, 0 and first term is already there. So from the second term onwards, I'll be calculating it till the nth term. Okay, so nth term is what the user will be providing. Okay, so whatever it is till that term will be iterating the for loop. Okay, right. So this is the concept. Fine. So I am writing my algorithm. So I'm saying A is equal to 0. So this is the first term of the Fibonacci sequence. And then I said B is equal to 1. So these two are the seed values. And then I am asking the user to enter the number of terms that he wished to see. So enter the terms, okay, or enter n. I'm asking the user to enter it. So this is wherein we are reading the input, and now we proceed further. So if n is equal to, if the user just wants the starting numbers, you're just, there is a chance that the user gives 0 and 1 also. So in that cases, just print the number and show the user. Okay, because there are no other terms to be calculated. And this is regarding the if part. So there is a colon here at the end, and this is the else part. If the user gives, else part will be executed if the user is giving other than 0 and 1. Okay, so if he is giving 2 or 3 or whatever, then the path of execution gets into the else block. So let me print the A and B on the screen, and also I want some space, so I'm aligning it properly. So I'm saying give space between A and B. So this is how we need to do it. And then I am writing the for loop. So for I in range. So this is the syntax now, like for is a keyword and I is a looping variable. And this is the syntax of the for, and range is a method, range is a function, and this function will be taking 2 arguments. The first initialized value and till where it need to iterate. So it needs to iterate from 2 second term till nth term. Okay, so n means that n minus 1th term, because Fibonacci sequence starts with 0. So 0 is the first is the 0th Fibonacci sequence. Okay, so I am turning it till n minus 1. Right. So this is the for loop, and now we need to write the logic. So we know that logic is that C is equal to A plus B, meaning that the previous 2 terms. Okay, so n minus 1th term is B and n minus 2 term is 0. Okay, so that's what we are trying to do here, and you need to set the values of after printing it. So C is the new term that you have got. Okay, now what you need to do is you need to change the values of A and B to the previous elements of C. Okay, right. So for that, what I'm doing is I have to put B into A. and I have to put C into B. Okay, right. So you cannot say C is equal to B and all that. Okay, because assignment operator will take anything on RHS into LHS. Okay, right hand side value will be taken into the left hand side variable. So you know that because this is an assignment operator and it works that way. So this is the logic I have written, and then I need to print the Fibonacci terms on the screen. So I'm putting the print statement inside the for loop itself. Okay, right. So what is calculated? The new term is calculated into C. So I need to put C in the on the screen, and then let me put a space. If I'm not putting a space, it will be printed one below the other. So then that will take so much of screen. So I'm placing it horizontally one after the other by putting spaces in between the terms. That's it, girls. This is the entire logic of generating a Fibonacci sequence or the series. Okay, fine. So I hope you understood the logic. This is how you need to give the for loop. So this is the looping variable. It was initialized to 2. And then this is very much similar to if you just wanted to construct the same in a while loop, then what you will do is you will make I is equal to 2. Then you will say while I is less than n, and then you will say I is equal to I plus 1. Okay, so it is the similar thing that we have taken into a for loop. Okay, so the same thing, if you want to convert this into a using a for loop, you can absolutely do that. But the thing is, you just need to change in this particular place, you just need to put I is equal to 2, and then you have to place while I is less than n, and somewhere around in the bottom after this print statement, you have to say I is equal to I plus 1. That's it. Okay, right. So this is what is an while version of for. Now let me save this and quit from this, and I have come back to the terminal. Let me execute this and show it to you. Okay, so the 5 terms, I want the 5 terms. So you can see the first 5 terms of the Fibonacci sequence are printed. Okay, right. I want, say for example, I want 10 terms. You can see that the 10 Fibonacci terms are printed on the screen. Okay, so the user will be giving how many terms that he want on the screen. Okay, right. Say I want 20 terms, all the 20 terms are here. See, I mean, you can observe that it is growing very drastically. Okay, so from 89, it has gone to 144. And from 144, you can see 233, and then it's getting double and triple, okay, as it moves forward. So this is what is Fibonacci sequence. If you just want to understand the growth rate of the Fibonacci sequence, and this is what it is. Okay, and it will take for example, it will take quite some time to calculate this one, because it's a repetition of the same thing again and again. So the time complexity will be more. Okay, so it will be an exponential time complexity to generate a Fibonacci sequence. So I hope this is understood. Yes.
Yes, ma'am.
Yes, ma'am.
Okay, so let us move on to your next experiment. So your next experiment, fourth experiment, is write a program to demonstrate working with lists in Python. So this is a very general question, which states that you just need to work with the lists. So you know what is a list? It's a data structure which is very much similar to like how you work with your arrays. You can every element in the list will be having a index number, and you can navigate the list with the index number and all that. So we already have understood what is a list in the theory part, so I think I needn't stress on it again. So I hope it would be good like I start showing you the process of this particular experiment. In your internal and external lab examination, I suppose like we'll be asking you to show certain operations. Okay, I'll be showing all the operations here, but in your experiment, like you need to show all these operations, or in case if we give A and B bit, and then maybe we'll give 4 or 5 operations from this, and then 4 or 5 operations from the other experiment. Okay, so it will go on like that. As of now, it's very a certain I mean, we are not very sure on that. because we haven't prepared the internal lab question paper yet. We are in the process of doing it. Yesterday only we completed doing the mid question bank and the quiz paper. I and sir only have prepared it. So now maybe like after a couple of days, like we'll be finalizing the lab experiments, how we need to give the internal lab exam and all that. So then I think I can give you a very clear idea on that. As of now, it's a very vague thing in my mind, so I just have put it out. So but maybe it may change. Okay, so don't fix on this that the question paper will be like this, but later on maybe it changes. Okay, right. So I'm into this shell. So let us create an empty list. So I can simply say L is equal to, and this is how the list is created with the square brackets. So whatever you want to, whatever elements that you want to put in the list are put inside this blank square brackets. Okay, fine. As of now, I just have created an empty list. So you can see list printed. Okay, right. So now I'm creating another list. So I say L is equal to, so I'm creating a list with elements in it. So the first list is I'm putting Sudha, and then I'm having another element over here which I'm saying Python, and then so say I'm putting some okay, pp class or whatever. Okay, so this is a list with strings. So you can see that it is a list of strings. Okay, so when you print it, like you will be getting a list which have all the string values in it. You can also have a list with integers. You can also have a list with the floating points. You can also include complex numbers inside a list. Okay, so it's not a mistake, or it's totally valid. So let me create a mixed type of values. So I'm saying 1 point. So this is the square. So I have put 1, and then 90.5. So which is on a floating point number. So then I say 2 plus 6j. Then I have Sudha, so I have a string and all that. So you can see that all these are valid. Okay, so I can have an this is a mixed kind of a list wherein I'm having an integer, I have a floating point here, and then I have a complex number, then I have a string. All kinds of data types can be there in the list. So this is regarding creating a list with mixed type of values. Now let us look into how to create a list of numbers. Numbers creating is very easy, right? I just say 1, 2, 3, and 4. So whatever is there, I'll put it. So this is a list which is of all integers. In the similar way, you can create for floatings and all that. I'm not showing you that because it's quite easy. You can do it on your own. And next is how you can access the elements using the for loop from the list. Okay, for that I'm writing the code over here. So for I, so this is a looping variable where it need to
Madam,
My
screen is
screen
not
is
shared.
not shared.
what? It just vanished now, or from the beginning it is not there? No, till I explained to you the third experiment, was it there?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay, when I started off list, was it there?
No, ma'am.
Okay, for list it's
No,
not there.
ma'am.
Okay. Now is it visible?
Yes, ma'am.
ఓకే. మరి ఇంతసేపు ఏం చేస్తున్నారు? ముందే చెప్పొచ్చు కదా నాకు. ఏమా? Okay. Can you see this? I said L is equal to this. Okay, I created an empty list. Okay. Give me a confirmation whether you have understood this or not.
Yes, ma'am.
Okay, so what is this? This is a list with the strings. Okay. So this is list of strings wherein all the elements here in the list are strings. Okay, when I print it, the list is printed. So here it is a list of mixed values. I have an integer, I have a floating value, and I have a complex number, I have a string. And then when I print it, it is giving me the list. Okay, so I can have mixed values also in the list. This is a list with integers, all integers, 1, 2, 3, 4, all integers. So when I print it, it is like this. Yes, okay.
Yes, ma'am.
Okay, now the screen is visible now.
Yes, ma'am.
Yes, ma'am.
Okay, so now let me show you how to access the elements of a list. So I am saying for I is the looping variable, I in range, then 0, 4. Okay, so a colon. So I'm writing the print statement here. So what you want? I want to print I. Okay, right. So you can see that all the elements inside the list are printed here. Okay, so I should say, okay, it's from 1 to, okay, I'll be directly saying L. Okay, so this is how I access it. Okay, so the name of the list is L. So this is how I access it. So you can see that all the elements from the list have been printed here, 1, 2, 3, and 4. Okay, so I just have to say that for I in L, L is the name of the list. So I just have to give it in this manner. You don't need to give a range over here, right? And in the similar way, I can also use the list comprehension. So I think you people are aware of list comprehension, right? So what is list comprehension? So you can create a list, perform certain arithmetic operations by using the list data. So I am taking a list over here. So the list is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. From these numbers, by using the list comprehension, I'll be finding out the odd square. Okay, first thing is I'll be finding out the odd number from the list, and after finding out the odd number from the list, I'll be doing a square of it. Okay, and create an other list. Okay, so the other list is odd list. So let me say odd square list is equal to. So now I'm doing the list comprehension. So in this list comprehension, so I'm saying, so we need to create an, odd square, right? From the list L, you need to find out the odd numbers, and the odd numbers you need to square it. Okay. So to do that, I'm using list comprehension. I'm doing it in a single line. So that is one of the advantages that you get with the list. So first thing is, before writing this, let me show you how I'm extracting each and every element from the list. So for I in the list L, right? So this is the syntax you know already. Now what I have to do is, after this, I am writing a condition. So if now you have to check on whether this particular I mod 2 is equal to 1. Okay, so if I mod 2 is equal to 1, it means that the remainder is 1, and it means that it is an odd number. If it is 0, then it means that it is an even number. So I just want the odd square, so I said 1. Okay, right. So I'm closing the square bracket over here. Now after extracting the odd number, what I have to do? I have to do the square. Okay, power of it, square of it. So this is exponential exponentiation operation that we have, so which will do the square of it. Now what will happen? The square will get into this particular odd square. Okay, so this is what we have done here. And let me show you, print this odd square and show you like what is the output that we have obtained. So you can see that the odd numbers are 1, 3, and then 5 and 7 and all that, and 9. So each and every odd number is identified. Now it is in I. So when this condition is true, then what happens? This arithmetic happens, which is I power 2. Okay, so first one part 2. Okay, so which is 1 square, which is 1 itself, and then you have 3 square, which is 9, and then 5 square, which is 25, and 7 square, which is 49, and so on. Okay, so 9 square, which is 81. Okay, so this is what you can do with list comprehensions. Rather than writing 2 or 3 lines of code, you can simply do an arithmetic inside it and create a list of from the obtained results. Okay, so this is odd square. If I just show you that there is no alteration in the original list. Okay, so this is the original list. Nothing happens to the original list, but from the data that you have in the original list, you're constructing another list over here, which is odd square. Okay, right. In the similar way, you can also do an even square if possible. So for this, I'll be saying it is if it is equal to 0, then I can if it is equal to 0, then it means that it is an even square. Okay. Okay, you can see the even square here, and not only this exponentiation, you can do any of the arithmetic operations that you desire. So this is all regarding the list comprehension. Now we'll see another operation that you can perform on the list, and what a list can have. List can have duplicate values. So you can see that I'm giving some duplicate values here. Okay, so it can consist of duplicate values. That is totally permissible, and so when you print it, it will just show you the duplicate values. Okay, find out the length of a list. So I can use this length method to find out the length of a list. So you can see that there are 6 elements inside the list, and it is showing us that it is 6. In the similar way, you can also sort the list by using the sort operation. So I can say sort, and that's it. Okay, so the list will be sorted. So here you need to put the name of the list before it to sort the list. Okay, when I print the list, you can see that the original list is altered in a sorted manner. So this is how it is sorted. If you want to sort it in a reverse manner, so that is also possible. So you can say L dot sort, and there is an attribute inside, a parameter inside this sort function, which is called as reverse. So this reverse need to be set to be true. Okay, so initially it will be as false, because it is false. By default it is false. That's why it is sorting in ascending order. If you want it in the descending order, so you just need to set it to be true. Okay, so now when you print L, you can see that all the elements are now in descending order. So this is what is regarding the len function and the sort function, wherein we have sorted it in the reverse and the forward and the backward format. And next I want to add something into the list. To add something into the list, I can use this append method. So inside the append method, I'm giving some 107, and I want to add it into L. Okay, right. So when I say L, you can see that 107 is added to the end of the list. And 107 is added at the end of the list. Okay, so just take a look at that particular point. Append is an operation which will add the elements to the end of the list. Okay, right. So let us also look into insert operation. So insert is an operation which will insert an element at a particular position. So you just need to mention the position. So I'm mentioning that the position is 3. At a 3 position, I want to insert 777. Okay, so let us now look into the list. So you can see that the indexing always starts with a 0, like your array. So 0, 1, 2, and at third position I want to insert 777. So 3 comma, the first argument into your insert is the position, and the second argument into your insert is the number itself. This is regarding the insert operation. Now, how do you access the elements inside a list? You can access it one after the other by using the while loop or the for loop, or else you can also use the index number to access the elements. So say I want the element at 0. So it is showing me that it is 1. Say I want the element at index 3, it is showing me 777. So you can navigate randomly into the elements of a list by giving the index number. Okay, fine. So there is also another method which is called as an extend method. So extend method will take a list and add it at the end of the list. Okay, so this is an extend method, so that's why every method will be having parenthesis. So do not forget that. And say I'm having a list over here. So I say Sudha, and then I'm saying PP and all this. Okay, so PP lab. Let me do that. And so what it will do is, this is a list. So one Sudha and PP lab is a list, and I am already having a list which is L, right? So this is the list which is L. So what will happen is this one Sudha and PP lab will add to the end of this particular list. Let me show you that. So I have done that, and let me show you L. Okay, when you have when you can very clearly see that these elements have been appended at the end of the list. Okay, right. If you want to append one element, you will be using this append, but if you want to append more than one element, a list into it, so you can actually use the extend. And in the similar way, I can also use the negative indexing, negative index to actually process the elements from the end of the list. So let me clear this off, and okay, fine. So say I'm having a list which is L is equal to 1, 2, 3, 4, and 5, and 6, and 7. So this is my list, and I want to access the list in with a negative index number. So I said L minus 2. So you can see that this is minus 1, 7 will be minus 1, and 6 will be minus 2, and so on. Okay, so if you want to process it from the beginning, this will be at 0, 1, 2, 3, 4, 5, and 6. Okay, so if you want to process it from the end, like, you will be giving a negative index. So the negative index is used to process it in the from the end. Then let us also look into the remove operation. So I said L dot remove, and then I need to pass on the element that I want to remove from the list. So I want to remove 5, so I just passed 5 into it. So you can see that 5 no longer exists in the list. The original list is altered over here. Okay, so these are all some of the operations that we generally perform on the list. In the similar, the other operations that you can perform are like the pop operation. So I think sir have already shown you the pop operation and all this, while showing you the stack implementation using list. So wherein you will be having this pop and push operations, append operations done there. So the pop operation will actually pop the element which is at the end. So the last inserted element, so which is 7, 7 is popped out. Okay. Now let me show you the original list. The original list is also altered. So these are very important for you to understand. Okay, like what is happening to the original list. What is the element that is popped up? These all can appear in your MCQs and also for your placement examinations. So this kind of understanding, the in-depth kind of understanding, is important. So that's what I have done here. In this, the other operations that I can do are slicing the list. So how can I slice a list? I can slice a list by giving the two numbers, the starting index and the ending index. So say here I'm having 7 elements. So let me slice it. Let me slice it and put it in another one. So I said S is equal to then L 2 is to then 5. Okay, so you can, when I print this S, you can see that the original list will be as it is. And okay, so the original list is as it is because I just popped out 7. So this is the original list. So the original list will be as it is, but what happened is I just want a part of the list which I just have cut it and I have put it in slicing. Okay, so I have cut it and put it in a list variable which is S. Okay, so the numbers from 2 to 5. Okay, so 2 to 5 is 0, 1, 2, right? So this one. Okay, 2, 3, and 4. Because the ending index means that 5 minus 1, 4. So the element still fourth index will be retrieved. So 3, 4, 6 are retrieved, and it is showing me the answer over here. So this is how you can slice it. If you're not mentioning any ending index, from the starting index till the end, it will be considering. Okay, right. So this is, you can also slice it from the end. So I can say that it is from minus 1 is to minus 3. So this also can be possible. Okay, so I can also navigate it from the end to the beginning. Okay. Okay, right. So minus 1. Okay, and I'm saying minus 1, minus 2, and minus 3. Okay. Okay, I have to minus 3 is 2, I'll give a minus 1. Okay, right. So now I'll get, okay, so I have to come from this one. Okay, so right, so minus 3 is to minus 1. So you can see that this is minus 3 and this is minus 1, the one before it, right? Minus 1. So ending index means that it is 1 before it. So 3 and 4 are extracted and put over here. So this is how you can use the positive index and also the negative index. So the last topic of your fourth experiment is multidimensional list. How do you create it? So I said L is equal to so multidimensional, right? So I'm having a list inside a list. This multidimensional list is also called as nesting a list inside a list. So the elements here are list themselves. Okay, so I can say that the first one is Python, and then I said 23. So this is the first element of my list, and the second element of my list is also a list again. Okay, so which can be 1, 2, 3 and all that. Okay, so then I close. So as you can see that this entire part is the first element of the list, and this entire part is the second element of the list. A list inside a list, which is called as nesting of the list. So when I print this L, you can see that it is showing me that this is the first element and this is the second element. Okay, now how do you navigate it? Okay, so this is considered to be the 0 element and this is considered to be the first element, right? So if you want to extract the elements, so 1, okay, and then a 1 will give you a 1. Okay, so this is again 0, 0, right? Okay, so what is 1 over here is the first dimension is that this element, because according to the list concept, this is 0, this is 1, 2, 3 and 4, right? In the similar way, this is considered, this entire thing is considered to be 0 part, 0 indexed element, and this entire part is considered to be the first element. So this is first 1, and this one that I have given is inside the list. So this 1 is considered to be at 0 index, and this 2 is considered to be at 1 index, and this 3 is considered to be at 2 index. So when I say L 1 and 1, it is giving me a 2. If I want the 1, so I need to say 1 and a 0, which will give me a 1. Okay, right. So this is how I navigate it, I access the elements which are in a multi-dimensional list or a nested list. That's it, Ma. Your experiment is over. The list operations and all that, I think I have shown it very clearly to you. Is it clear? Experiments are also in such a manner. Write a program to demonstrate working with tuples in Python. So that is your next experiment, which is experiment number 5. Okay. So what is your experiment number 5? So the next experiment is all about tuples. Okay. Right. So working with tuples. Right. So it took it as a command. Well. So let us start creating a tuple, empty tuple. So tuples, in the previous session, we have seen square brackets. Associating a square brackets will make it a list, and a parenthesis will make it a tuple. And we already know that tuples are immutable, meaning that there won't be any append and all that. Once you create a tuple, it is tuple. Okay, right. You cannot make any changes to your tuple. And this is an empty tuple, so you can see that when you print, it is showing me that it is an empty tuple. So let us create a tuple now, so which is a tuple of strings, so which is having only strings in it. So then as a CSE, okay, so this is my tuple. So this is Sudha and CSE, a tuple of strings. Okay, you can also create a tuple from a list. So say I'm having a list like this, 1, 2, 3, and then I can convert this list into tuple by passing it into the method which is tuple method. Okay, so I just have sent L into it, and you can see that it has converted into a tuple. Okay, so or else I can also say that X is equal to, and then okay, so X is equal to, and then when I print X, it will become a tuple. Okay, so this kind of assignment is also possible, and tuple is a built-in method which will actually convert one type to another type. And the next one is you can also create a tuple by say giving it a string. Okay, so say for example, I'm giving a string, and the string is Sudha. Okay, so now let us see how this string is converted into a tuple. So you can see that each and every character from the string has become an element into a tuple. Okay, so this has become an element in a tuple. You became an element in this way. A string is converted into a tuple. Okay, right. So you can also have a mixed values elements in a tuple. So I can have okay 12 comma, then I have a integer, and then I have a uh, uh, you can say a string, and then I have a floating value. All these are permissible. Okay, so I do have something like this, and so this is a tuple. Okay, so a tuple with mixed data types. And how can I access the elements in a tuple? In the similar way, like how I have done it for the list, I'm doing it in the similar way. So I'm writing a for loop, and I'm just navigating through each and every element in the tuple, and these are all the elements in the tuple: 12, Sudha, and 23.67. So all this is printed on the screen for you. Okay, so this is how you navigate through each and every element of the tuple. Right. So we'll see the next concept, which is nesting of the tuples, combining the tuples together. So I have a tuple which is T1. T1 is equal to, so I have 0, 1, 2, 3. So this is my first tuple. And then I have another tuple. So I have another tuple of strings, which is Python, and then CSC. So this is my second tuple. Then I said T3 is equal to, then I can pass this T1 comma T2 into it. Okay. So when I do that, what happens is these two will be combined together into T3. Okay. Right. So what happens is this is what is called as nesting of tuples. You can see that this entire tuple has become one element in your T3, and this entire tuple has become as the next element in the resultant. Okay, right. So this is how you create nesting of tuples. And T1 and T2 will not change. Okay, so they'll be as it is. You're putting them together into T3. Okay, so that's what is called as nesting of tuples. Now let us see another operation of creating a tuple with repetition. So I said T1 is equal to, then I'm having a tuple here, which is Sudha, and then I said star and then 5. Okay. So when you look into T1, you can see that Sudha is there here. Okay. So repetition of the elements can be done by using the repetition operation, which can absolutely be applied on the tuple. And if you want to count, okay, so I just have to give the name of the tuple, which is T1 dot count, and then inside this I'm saying count how many times Sudha is there in the tuple, so it will give me that count over there. Okay, right. And how can you access the elements of the tuple? So say I'm having a tuple T1 is equal to 1, 2, 3, 4 and 5. Okay, so now I want to access the elements of a tuple by the index number. So I can say T1 and 1. Okay, so when you do that, see, okay, so this is at 0th index, this is at the first index. So I want the element at the first index, so 1, and you can say that 2 has obtained. You have obtained the element which is there at index number 1. Okay, so this is another operation, and the other operations are unpack operations. Let us look into what is meant by unpacking. Okay, so here I have 5 elements in T1. So I want to unpack each and every element into a variable. So I'm saying A comma, then B comma, C comma, D comma, E, and then T1. Okay, so what happens now is each and every element will go in sequence to the variables that I have listed here. 1 will go in A. So when I show you that 2 has gone into B, and 3 has gone into C, and D gets 4, and then E gets 5. Okay, so this is unpacking of a tuple into variables. So what and all we have seen so far? We have seen how to create an empty tuple. We have seen how to create a tuple of strings. We have seen how to create how to convert a list into a tuple, then built-in function which is tuple, and how it reacts when you give a string into it. And then we have seen mixed data type tuples, then accessing a tuple within a loop, using a loop, and then we saw nested tuples, how to create them, and we saw repetition of the elements of a tuple, and then count operation, and then how to access an element of a tuple using the index value. And finally, we have seen unpacking of the tuple elements into variables. Okay, now let us look into more operations of it. So the other operations are concatenating tuples. So how can you do that? Okay, so you can just use a plus symbol to concatenate two tuples together. So I said T1 is equal to, so I'm just having 1, comma 2, comma 3, and then T2 is equal to, then I have 5, 6, and 7. So these are the two tuples. Then I said T3 is equal to T1 and plus T2. When I print T3, you will understand that how the concatenation happened. So the joining, one new tuple has created, which is T3, which will be having all these elements in sequence of the order that I have given. T1 comes first. So the first T1 elements comes before the T2 elements. If I just do it in the other order, say T2 comes first and then T1 comes later, then what happens is the order will change. Okay, so T2 elements will come before the T1 elements. So this is what is called as concatenation of tuples. But the T1 and T2 remains unchanged. They will be as it is. You're just combining those elements into a new set of elements and call it as tuple 3. That's it. Okay, right. And then so we'll see the slice operation. So the last concept of your tuples. So you can also slice the elements. Okay, so say I'm having T1 is equal to, let me create a tuple. Okay, so tuple, and then okay, Sudha Python CSC. Okay, so I just created it, and you can see this all the elements in the tuple. Okay, so now let us apply the slice operation on this particular tuple. So you can say T. So the name of the tuple is T1. Then give a square brackets and give the indexes. Okay, so you know that this is at 0 index. So based on that, whatever you want, you can see. Okay, so you can give that. So I can say from 0, then so I'll be saying 5. Okay, so then you can see that only Sudha have cut from the tuple and it came out. Okay, so the original list will be as it is. Okay, fine. I just want a slice of the list. I can actually use this kind of methodology to actually extract the part of list. It needn't be the first part, it can be any part. Okay, but the numbers need to be there in sequence. Okay, right. And if you want to reverse the list, then you can say T1 and let us reverse the list. So I got the last element of it. I need to give the columns also. So I just need to give the columns, and then I said -1. So what happens is the list will be reversed. Okay, so this is what is the reverse of the list is printed. The original list is as it is. Okay, if you want to catch this in another variable, you can say that S1 is equal to and do this. Then S1 will be holding all these elements in it. Okay, and if you want to print the range, okay, this is what I have shown you, the range. Okay, say for example somewhere around in the middle, T1 some range. Okay, so I'm saying from 4, I want it till 8. Okay, so it will absolutely do that. So this is how you give a range. This is how you give a negative index to reverse the elements in the list. This is how you get the last element of the tuple, and this is again a range. Okay, fine. So that's it, girls. This is all the various operations that you can perform on a tuple. Clear or not?
Clear, ma'am.
Clear, ma'am.
Clear. Okay. So do you want me to start the dictionaries, or you will see the concept tomorrow?